Underlay automation with SDN Assist. This is a feature of OSM for enhancing the automation level we get when we use SR-IOV. By default, as Joe was saying, we work with tunnels in OpenStack. I mean, we create virtual machines, and whenever we are assigned to an internal network, like the SGI network in your case, for example, and every single virtual machine connects to a virtual switch, and if you need to go out of the server to another server that where a virtual machine belongs to the same network, then you would communicate through VXLAN tunnels. And the physical servers, sorry, the physical switches are not aware of that communication. They just transport VXLAN. They are transport Ethernet packets, Ethernet frames. So this is the way it works usually. VXLAN tunnels are controlled by OpenStack. The VTEPs and the endpoints, so the endpoints of these tunnels are the OpenV switches that are controlled by OpenStack. So it takes care of that communication. So OpenStack implements like an SDN controller in Neutron that takes care of configuring the tunnels that you need so that your virtual machines are assigned to a layer 2 network, even though this can be a layer 3 network, it can be an MPLS network, it can be a multi-data center IP network. And you will still see the VMs in a layer 2 if you assign them to the same network, just because of this feature that works by default in most distributions of OpenStack. Okay, but the problem is that these OpenV switches perform up to 1 gig, more or less, unless DPDK is enabled or similar techniques. And you would, in the best case, take you to 10 gigs, and that's it. It depends on how many cores you can dedicate to the DPDK feature. Basically, it bypasses the kernel and uses OBS directly in the user plane, and that gets more performance. I mean, eliminates the Linux stack, default stack for networking. So physical interfaces are just used for transporting the tunnels. They only require IP connectivity. This can be internet. It can be anything. As long as there is IP connectivity, these tunnels will work. Okay. This is by default what we use. What we use between virtual machines. If we expose, of course, the virtual machine to a public network, you would usually have you still have a switch, but you will probably go through a regular VLAN to the physical network. That's a little bit different. In SR-IOV, we assigned the NIC directly to the virtual machine. So there's no switching occurring at the server level. So how do we handle these tunnels that we used to have? By default, there's nothing. No need to configure a VLAN here, another VLAN here, another VLAN, the same VLAN here, and then expect that the communication flows. Or if it's an IP network, or I'm using EVPN, for example, I can use these switches as VTEPs and make them start that handle the tunnels, the VXLAN tunnels. That's another option. However, it's not automated by default. There's no one taking care of this, unless there is a manager of the vendor of the switches that detects that the VM was created and needs something about it. But that's not very popular. So who takes care of the end-to-end connectivity? That's where SDN Assist comes in. SDN Assist orchestrates SR-IOV or pass-through, and also, well, after OSM has orchestrated SR-IOV or pass-through connections to the switches, then SDN Assist gives the ability to create these layer 2 connections between the virtual functions that were assigned. So OSM needs to have control of 2 layers. The OpenStack part to be able to assign the SR-IOV ports, and an SDN controller or a network manager that would let OSM configure the switches so that the VLANs are configured, the VXLANs are configured, the open flows are configured, and so on. So in this diagram, the example is an open flow, but and this is outdated. Actually, it would we would use here. Sorry, I will update that later. But we would use plugins to connect to the SDN controller. It said before OpenFlow plugin. I just corrected that and put just an API because it communicates, or it said OpenFlow API, but it's just an API, a generic API now. I mean, generic models, methods that connect to the API of the SDN controller and interconnect two given ports or multiple ports or whatever I want to do. Okay, so the SDN Assist module would support plugins for talking with different SDN controllers or network managers, but the methods that we would consume from Arrow are the same. We just want to connect 2 ports or 3 ports or whatever amount of ports that we want to connect that have this characteristic. So at the end, we would have open source MANO through plugins controlling this SDN controller or network configuration managers, so that the switches can be configured to create this communication, which can be VXLAN tunnels, it can be open flows, it can be VLANs, can be whatever the switches support. As of the previous release, we supported ONOS, Arista, Open Daylight, and Floodlight. I think that in release 8 we're going to add Gianpietro Contrail, but I'm not sure if it's available. Sorry, it is available. It is available in 8.01. So I need to update this slide. Okay, the requirements. Well, we need a beam that supports SR-IOV that was pre-configured with SR-IOV. We need a SDN controller that is compatible with an SDN Assist feature that is reachable from OSM. For certain plugins, like OpenFlow, for example, we need the SDN port mapping file, which is just a mapping between the VF numbers, VF addresses, and the ports, so that OSM knows and the ports of the switches, so that OSM knows that if OpenStack assign a given PCI address, then it knows to which port it corresponds to in the fabric. So this is a file built once. The Beam user must have admin privileges in OpenStack to access this PCI information, or the privileges to get this PCI information. And finally, we would need to configure the Beam and configure the SDN controller in OSM, so OSM is aware of an SDN controller. We have more information here in the guide. So in our scenario, we want to enable that in here. What should we do? Basically, we need to add an SDN controller, which is already available at this address. We would just need to change I suggest to change this ONOS XX to your tenant. But the IP address is the same for everybody. So this creates an SDN controller in OSM. Then we download the mapping for Etsy infrastructure, which is here. We download it anywhere. And then we update our Beam with the given controller that we created and pass it the mapping file that we just downloaded. So that connects everything. And then we are ready, and we modify our descriptors so that we use SR-IOV instead of ParaVirt. you will see that there are commented lines that already say SR-IOV. You will just need to uncomment it from the dashboard if you want of OSM, and comment the paravirt line or delete it so that SR-IOV is enabled. And just do it at the S1 interface. So it would be Ethernet 0 in MAC/MAC gateway, and it would be Ethernet 1 in the SRS LTE emulator. Both belong to the same VNFD. This is the multi-VDU VNF that we have to the right here. So we are modifying these ports that interconnect both. And that's it. Then, well, I'm sorry for this. This belongs also to the previous Hackfest. We are not using scripts. We are using just the OSM commands. So we will launch the network slice as we usually do, and that's it. And the rest would be the same, but we will have a better performance between the elements that we configured with SR-IOV, and we'll be able to check that in, well, optionally, and I will show you how we can check it in the SDN controller.